Welcome back. Today, we're diving into the algorithm that took the absolute chaos of the early internet and basically gave it a table of contents. This is the story of PageRank, the brilliant idea that powered Google and completely changed how we find, well, everything. I want you to really picture that. You walk into a library with billions of books, no catalog, no librarian, just endless shelves with zero organization. That is exactly what the early web felt like. It was this massive, incredible collection of information with no good way to find anything. So how do you even begin to solve a problem on that scale? To really appreciate how genius the solution was, we first need to get a handle on the sheer scale of the problem that early search engines were staring down. Think about this number for a second. By 2023, the web had ballooned to over 1 billion websites. And even back in the late 90s, the growth was just insane. It was like trying to map an entire galaxy while it was still expanding in every direction. This created a colossal challenge for anyone trying to organize it. And, the challenge wasn't just about the size. It really boiled down to two huge problems. First, efficiency. I mean, how on earth do you search billions of pages in a fraction of a second? And second, maybe the even trickier one, accuracy. How do you make sure the pages you find are actually relevant and not just a bunch of junk? So, the first attempt to solve that accuracy problem, it seemed logical, right? But it had this critical and frankly kind of funny weakness that people figured out how to exploit almost immediately. The first big idea was something called TF-IDF. And the logic was super simple, really intuitive. Basically, if you searched for the word pizza, the search engine would just rank pages based on how many times they mentioned pizza. The page that said pizza the most was probably the most important page about pizza, right? I mean, on the surface, that makes perfect sense. But here's the flaw. This whole system was built on one giant assumption, that web pages were being honest about their own content. It just trusted them. It figured a page's text was a reliable sign of its topic. And as we all know, you can't always trust what you read on the internet. And this, of course, led to a practice people called term spam. Website creators got wise to this really fast. They realized they could totally game the system. So, for instance, a local pizza shop could hide the word AI 1,000 times in its code using invisible text. You'd never see it, but the search engine would. And suddenly, a pizza website is ranking super high for artificial intelligence. The system was just broken. So clearly that wasn't going to work. A totally new way of thinking was needed. The solution couldn't rely on what a page said about itself. It had to be based on something much, much harder to fake, its reputation. And this is where the genius of the PageRank idea really shines. It completely flipped the logic. Instead of analyzing what a page said about itself, it looked at what other pages said about it. A hyperlink from one page to another was suddenly treated as an external vote of confidence. And this quote gets right to the heart of it. It wasn't just about counting the total number of votes or links. The real lightbulb moment was that not all votes are created equal. A link from a major trusted news site should count for a lot more than a link from some random personal blog. Importance, it turns out, is transferable. Okay, so how does this clever idea actually work? Let's try to visualize the process without getting bogged down in all the complex math. The best way to think about it is as a continuous web-wide election. Every single web page starts with a certain amount of importance score, or rank. It then divides its score equally among all the pages it links out to, effectively casting its votes. Your page's new importance is simply the sum of all the votes it receives from other pages. This process is called power iteration. You start by giving every single page on the web an equal score. Then, in round 1, every page passes its score along its links. In round 2, they do it again with their new scores. You just repeat this calculation over and over until the scores for every page stop changing significantly. They reach a stable state. To make this concrete, let's forget about 1 billion websites for a second. Let's imagine a tiny internet with just 3 pages: page Y, page A, and page M. We're going to watch how their importance scores evolve. All right, here we are at iteration 0. This is our starting point. Before any votes are cast, the algorithm assumes every page is equally important. So with 3 pages, they each start with 1/3 of the total importance. Now, watch. After just one round of voting, the scores shift dramatically. Page A must be receiving some important links because its score shoots way up while page Y's drops. A hierarchy is already starting to emerge purely from the network's structure. And if we jump ahead a few more rounds, you can see the scores settle into a stable state. Page A is the clear winner with 60% of the importance, while Y and M level out at 20%. We've just found our most authoritative page, not by its keywords, but by its position in the network. Ultimately, this iterative process isn't just a calculation, it's a discovery. It lets the web's own structure reveal the authority of each page, finding the network's natural center of gravity. You know, this algorithm didn't just give us better search results, it fundamentally changed how we establish trust and authority online. PageRank was revolutionary because it was the first system to understand that the web wasn't just a collection of documents, it was a graph, a network of relationships. By treating links as votes, it could find genuine authority instead of just keyword density. This was the breakthrough that allowed Google to deliver on its mission to organize the world's information and make it universally accessible and useful. And that leaves us with a fascinating question for today. PageRank's core idea was to find a reliable signal for trust, the hyperlink. But on today's web, dominated by social media shares, AI-generated content, and walled-off platforms, what is the equivalent of that trustworthy vote? What signals can we use to find authority in the noise now? That's the challenge the next generation of search is trying to solve right now. Thanks for joining us.